Can you freeze fire? Exploring the science of temperature. Have you ever wondered, can you freeze fire? It's a question that sparks curiosity. Fire is mesmerizing and at the same time a mystery wrapped in heat and light. Today, we're diving into the fascinating world of temperature and states of matter. By using common substances like alcohol, dry ice, and supercooled water, we'll explore how extreme temperatures affect these materials and learn what happens to matter at different temperatures. Join me in this scientific adventure where we'll unlock the secrets behind fire and its relationship with freezing. Understanding fire. Let's first talk about what fire really is. At its core, fire is a chemical reaction known as combustion, which occurs when heat, fuel, and oxygen come together. This process generates heat and light, creating the flames we're all familiar with. But did you know that fires can range in temperature from around 200 degrees Celsius to as high as 182 degrees Celsius? That's incredibly hot. It's also important to note that fire exists primarily in a gaseous state, while surrounding materials may be solids or liquids. Understanding fire gives us a foundation to explore temperature and how it influences different forms of matter. So while we can't freeze fire itself, we can examine its behavior alongside other substances affected by temperature. The states of matter. Now let's quickly recap the states of matter, because they play a big role in our exploration today. Matter usually exists in four primary states: solids, liquids, gases, and the less common plasma. In simpler terms, solids have a definite shape, liquids take the shape of their container, and gases expand to fill whatever space they're in. Temperature is key. When temperatures rise, substances can change state. For example, heating a solid can turn it into a liquid, like ice melting into water, while heating a liquid can turn it into a gas, think water boiling into steam. On the flip side, cooling a gas may condense it into a liquid, and further cooling can freeze that liquid into a solid. We're about to see how alcohol, dry ice, and supercooled water all demonstrate these transitions, giving us insights into extreme temperatures. Using alcohol to explore temperature. Let's jump into our first experiment with alcohol, a common household item. Alcohol, like rubbing alcohol, has a low ignition point compared to other fuels, which is why it burns easily. When we heat alcohol, it quickly catches fire, creating a beautiful flame. But what happens when we cool it down? Alcohol freezes at about -128 degrees Fahrenheit, 89 degrees Celsius, much lower than water. We can do a simple experiment where we put alcohol in a shallow dish and place it in the freezer. As it chills, we can monitor how it thickens and eventually solidifies. This contrast between its burning temperature and freezing point is a great way to show how extremes in temperature can result in dramatic changes to the state of a single material. Dry ice experiment. Next up, let's explore dry ice. Dry ice is solid carbon dioxide, and it sublimates, meaning it changes directly from a solid to a gas without turning into liquid first. This transformation happens at a chilling temperature of -78.5 Fahr, 61.5 degrees. In this experiment, we can take dry ice, place it in warm water, and watch as it creates fog-like vapor, which is actually carbon dioxide gas mixing with water vapor. It's not only a super cool visual effect, but it also represents how temperature differences can dramatically change the way substances behave. The comparison is clear. While fire represents the heights of heat, dry ice embodies the depths of cold, showing us two extremes. Isn't it fascinating how they both play with temperature? Supercooled water experiment. Finally, let's tackle supercooled water. Supercooling occurs when water is cooled below its freezing point, 32 degrees Fahrenheit, 0 degrees Celsius, but remains in liquid form. To see this in action, we can put purified water in the freezer and leave it undisturbed. When we take it out and introduce a small disturbance, like giving the bottle a gentle shake, you'll marvel as it instantly freezes into ice. This cool demonstration highlights how precise temperature control allows water to exist in these states. It emphasizes how temperature affects not just fire, but everyday materials, making science relatable. Conclusion. So can you freeze fire? Not really. But through these experiments, we've uncovered how deeply temperature affects different states of matter. From the mesmerizing flames of burning alcohol, to the captivating fog of dry ice and the surprising behavior of supercooled water, these demonstrations illustrate the intriguing relationships between heat, cold, and matter. I encourage you to try these experiments at home, enjoy the science, and share your results. Understanding temperature helps us explore and appreciate our world in exciting ways. Call to action. If you enjoyed this scientific journey, don't forget to like and subscribe. Share your thoughts in the comments, and stay tuned for more fun experiments.